Hi folks, welcome to the video on box plot basics and interpreting box plots. So let's do a quick refresher on what a box plot is. But a box plot is also known as a box and whisker plot. And a typical one looks something kind of like this. All right, so we've got a box. And somewhere in the box, we have another line. And then we have these whiskers. Okay. And so in this box and whisker plot, we have a few sort of indicators in the data, okay? And so if we start off with this leftmost whisker, all right, this one right here, this one is where the minimum value is, okay? The minimum value. And then between here and here in this space, we have some data points, and they are the first 25% of the data points. And so we refer to this as quartile 1, okay? But that's a lot of words to write, so we typically just write Q1 for quartile 1, okay? Now, every time we move another line, we basically go another 25% of the data. So 25% of the data is here. And then another 25% is between the first line in the box and the middle line in the box, okay? This one is known as the mean, or sometimes we refer to it as quartile 2, right? Now, the next 25% of the data goes between the middle line and the right edge of the box, and this gives us quartile 3. And then when we get all the way to the end, this is where our maximum is, okay? And so basically this chunks our data into 25% clumps, all right? So there's 25% of the data here, 25% of the data here, a quarter of the data here, and a quarter of the data here, okay? Now, a few other things that we should know when we look at a box and whisker plot, the thing that it tells us about in the data is it tells us about the spread of the data, okay? So it tells us the spread of the data. And what it ends up happening, because sometimes we have sort of outliers in our data, numbers that are like way smaller than all the other numbers, or numbers that are way bigger than all the other numbers, okay? And if we had outliers, we would mark them with X's. Okay, so if there were some X's that were outside of the whiskers, those would be considered outliers. Right? But if we have outliers, it turns out that finding like this as a measure of spread is a little bit less accurate, but we actually find out sort of how wide the box is. And how wide that box is tells us about where that middle 50% of the data is, helps us determine the spread, okay? We have a special name for this. So if we take the distance from Q3 to Q1, we call that the interquartile range. And again, that's kind of a long word, so we'll just say IQR, interquartile range. And the way we find that interquartile range is we do the difference between Q3 and Q1, okay? All right, so here it is all on one page, a little bit of the basics of what a box plot is. And in this video, I actually want us to focus on how we interpret a box plot. Like, what does it mean? What kind of data could we have shown with it before we talk about how to make them? Okay, I think the construction part is a little bit less important, but being able to read it is definitely important. All right, so let's take a look at this example. So given the following box plot, answer the questions. Think of an example in words where the data might fit into the above box plot. In 2 to 5 sentences, write down the example. And after that, we'll take a look at the quartiles and what we think that means, okay? So one thing I want us to notice is we've got a right whisker. So maybe we label these. We've got our maximum. We have our Q3. We have our Q2. We have our Q1. And if I were to guesstimate, I think that's about 95. Q2 is about 20. And it looks like Q1 is actually 0. Okay. Now, in addition to Q1 being 0, we might notice that there's no left whisker. Okay. In other words, we don't have this whisker out here. And so when there's no whisker visible, what that means is the minimum and the Q1 are the same value, okay? So if I go back here, not only is Q1 equal to 0, but the minimum is also equal to 0, okay? Now, let's think about a data set that might give us this box and whisker plot, okay? So I'm going to assume that we have something with 20 data points, okay? If I have 20 data points, that means that in each quartile, I've got 5 data points, okay? And so let me sort of divide this in. My Q1 is 0. My Q2 is 20. My Q3 is 95. Let me scoot this over a little bit. And my max equals 150, looks like. Okay. So in order for the first 5 data points to get to a Q1 of 0 or a min of 0, we know that those 5 all have to be 0. Okay, so the first 5 data points are 0. Now, if Q1 is 0, it means, and I have another 5 here, it means I'm actually taking the average of the data in spot 5 and the data in spot 6. And that average needs to be 0. So we got to have a 0 there. Okay. Other than that, we can just make up 4 other numbers, right? 4 other numbers. So let's say 3 and 11 and 14 and 18. Okay. Now, if I want my Q2 to be 20, that means the average of the data points in spot 10 and 11 has to be 20. So if it's 18 on one side, then it better be 22 on the other, so I can add them together, find the midpoint, and it's 20. Okay. Now I'm going to keep going. I want to list 4 more data points in this third 25% of the data. And I want to make sure that my Q3 is 95, okay? So I could say 22, 30, 40, 70, and let's say it was 90 over here. That would mean that on the other side, in that spot 16, I would need 100 because 90 plus 100 divided by 2 gives me 95. And then I got to get all the way up to a max of 150. So 110, 120, 130, and 150. Okay. And so if we see we've got 5 data points, that's 25% of the data, another 5 points, another 25%, 25%, 25%. Okay. Now, let's actually think about a question that we might have asked in order to get this data, all right? I've got a lot of zeros and then a few with the higher values. Maybe a good question is, how much cash do you have right now? Okay, so if I asked you to open up your wallet right now and say, how much cash do you have? I'm betting that a lot of us are like, I don't even know where my wallet is. I just have Apple Pay and that's what I use everything for. And that might be this clump of people, right? But then we might have people who are like, ooh, yeah, I just spent a few dollars the other day. I got some change. It's just $3. It's not very much. But we might have a few people who are like, I like to keep at least $100 in my wallet at all times, right? But maybe that's only 25% of the population, whereas more people are carrying like half of the people are carrying $20 or less, okay? All right, so that is one possible example, and there's a lot of other ones, and I would encourage you to think about like what some of those might be. All right, second question, what does it mean to have the first and second quartiles so close together while the second to third quartiles are far apart? All right, and so if we look back at this box, we see that sort of Q1 and Q2 are much closer together and Q3 is way far out. And so if I were to answer that question, all right, I may see something like the 5 data points in the second 25% are closer together. All right, so if we look at the numbers we made up, 0, 3, 11, 14, 18, those are much closer together, but in that third quartile, the smallest value is 22 and the biggest one is 90. That's like a really big spread, okay? So the 5 data points in the third 25% are much more spread out, okay? And so if we have sort of more space in between here, that means it's more spread out. But if things are closer together, then it means that the data points are actually closer together, okay? All right, let me know if you have any questions.